When you do something long enough, you start to pick up new techniques, or secret tricks. So take these things I learned. It's dangerous out there. Have you ever heard of the goes to operator? It looks a little bit like this. We initialize our counter, then we do our standard while loop. And it looks like this. So this is while I goes to 0. Let's go ahead and print out I. There we go. You should note it does not start at 10. It went straight to 9. But let's break this down. This could actually be rewritten as I minus minus greater than 0. It is literally the same thing. So it's decrementing and then checking if it's greater than 0. But we can call it the goes to operator. Kind of interesting. And we got the same thing. Another handy and very useful thing are macro functions. So like a standard define, let's say we want to get the size of an array. We can have a handy little macro that does it for us. All this is doing is dividing the amount in memory by the size of the field. This could be useful if you're passing an array to a function and you want to get the length of it without asking for it in the function signature. So for instance, an array is created of 200 of ints. This would take the size of in memory that 200 and divide it by the size of an int. We go array should be 200. Length is, use our macro. Usually I use X, but I was talking about an array. There you go. We got the size of our array of 200. Another handy, useful macro I like to use is a debug, like a debug printer. Yeah, I should mention when we define our macros, this is kind of like our function declaration, and this is like defining the function, and this is kind of like the body of the function. We don't use curly braces here. So we're going to type in, we have an error. %s should be what we pass to it. %u is interesting because we can take, first we need what we pass to it, then we need the file, and then we have our line number, and then we pass this args. So this debugger is going to print out to standard error the line error, what we pass to this debug function, and the file name and the line number, which can be very useful when your project gets very large. So let's say we want to debug here. Our array should be 200. Oh, you know what? There's not supposed to be a comma there. I know it seems like there should. There we go. We got our error, main.c at line 19, and we got our statement. Pretty awesome. Now, another handy tip and trick is using bit manipulation. For instance, did you know we can use the AND instead of the modulus to check for even or odds? Say we have a number 5. We can go num and 1. So if that evaluates to true, which will be 0, then we have, 1, odd number. We have an odd number. Else, we should go ahead and say we have an even number. Oh gosh. Let's go ahead and see what happens. We get odd. And let's go ahead and change this with a 4 and run again, and now we got even. We'll have to look at this in binary, but for example, a 5 is a 0, 1, 0, 1, and we're going to AND that with 0, 0, 0, 1. Now, if you remember anything with when you're ANDing, as long as the two are the same, if a 0 and a 1, you get a 0. If you get a 1 and a 1, you get a 1. So we either get a 0 or a 1, and that makes it odd or even. So with the 4, we have a 0, 1, 0, 0, which gives us in binary 4. And we're going to AND that with 0, 0, 0, 1. And the result of that is a big fat 0, which is false. And while we're on the topic of bit manipulation, how about shifting all the bits by left or right by 1 to divide or multiply by 2? bit manipulation to divide by 2 or multiply by 2 is so much faster. But you probably won't actually need it unless you're doing very heavy math calculations. But let's go ahead and look at it anyways. Okay, we have the value of x, which is going to be 5. Let's just do a handy print statement. We're going to do %d shifted to the right by 1 is going to equal %d. I take x shift by 1, and let's yank that, paste it, and we're going to go shift to the left and shift to the left. All right, let's see what that does. So 5 shifted by 1 is 2. 5 shifted to the left by 1 is 10. So shifting all the bits to the left by 1 multiplies the value by 2. And shifting all the bits to the right by 1 divides, but we lose the remainder because that digit, that binary value that's all the way to the right, the last digit will be shifted over and lost. So let's say we have the value of 2 in binary, that's 0010. We shift it over to the left by 1, that becomes 0100. So 2 shifted to the left by 1 is 4. Now let's take a look at shifting 5 over to the right by 1. In binary, 5 is 0101. Shift that to the right by 1, we get 0010. We lost that 1 all the way to the right. How about a ternary operator? Instead of this multi-line if statement, if else statement, we can do this in one line. So instead, we can do num and 1. We put a question mark. So if that is true, we print odd. We put a colon. That is meaning if it is not or else, even. Let me go ahead and comment this out. And so we can see that it should print an even. There we go. We got our even right there. Let's go back and change that to an 11. We get odd. But we can also capture a value and store it into a variable. So let's say we want the results of this num. So we just put a string even. My mistake, I forgot to set that equal. There we go. And now we can just printf our string, our result. So now we should see odd. Same thing. And I'm willing to bet you have never heard of atexit. The atexit function allows us to call functions upon the program closing. That could be useful for any cleanup. But what we need is the standard lib.h header. So let's make a function here. We'll call cleanup1. So I'm just going to print out the name of the function just so you can see an example of multiple atexits. So let's say atexit we want to call cleanup1. We just spell it correctly and then we can actually use it. And then let's say we have something here and say, oh, well, atexit, make sure this thing happens. We'll have cleanup2 called. And then, oh, yeah, right before this, we forgot, yeah, we need atexit, make sure cleanup3 happens. So now if we compile and run it, you notice I put them all through the code, but they only happen near the end. So cleanup3 was called, then cleanup2, and then cleanup1. So let's go look back in our main.c file. If you notice, cleanup3 was the last one we added, cleanup2 was the second, and cleanup1 was the first. So even though we put it here, we put them through our code, it did all the code first, and then right before we got to the end here, it called those functions. So you notice cleanup3 was called first, then cleanup2, and then cleanup1. Now that's because this acts as a stack, and a stack is last in, first out. Just remember that, they're called in that order. So whichever order you put them in, they will be reverse order. Awesome, way to level up by doing. The code will be hosted on GitLab. A link will be in the description. And thanks for watching. Be sure to subscribe, like, share, and comment to defeat that algo monster.